Okay, so let's get started. Hello, I'm Inzul Lutfa Zahri, and I'm reading BSc Information Technology in University of Jaffna. First of all, a warm welcome to you all for being here. And secondly, I'd love to congratulate you all for choosing ICT as a subject where many refuse to do so. So you people have already taken your first step to future. Kudos to you all. Okay, so as you all may know, today our topic is going to be number system, which belongs to your grade 10 syllabus, the third unit, the data representation in computer. So as you know, we are going to discuss about it, and I'll show you how we are going to do the easy ways of conversions and all those things. But before getting started, before getting into the subject, I would like to start with a simple question. So what is that question? The question for you is going to be this. Why did you choose ICT? So come on, answer me. Like you can ping me directly, ping me a message directly. So tell me, why did you choose ICT? Okay, I can see so many answers. Okay. And come on, answer everyone. Okay. You love maths and you can understand very well. Okay, and yes, it would help your future to future purpose. Yes, interest in technology. Okay, that's all. I can see 30 people in the classroom to get to know about technology. Easy to study about technology. Okay, so fine. Your people are saying, yeah, I like how to be a software engineer. Very good. So yeah, so your people are saying that I am I like technology, it's easy and all those things. Okay, now tell me, is ICT easy for you? Your syllabus, is it being easy for you? Yes. Yes, of course. So you people, so it's very easy, right? Yes, that's the spirit. Because I have heard many people saying ICT is hard. So when I was about to take ICT in O level, uh, teachers, including teachers, some of them were like, don't take ICT because it's going to be hard. So it will affect your results. So instead of ICT, take any other basket subjects. But I didn't listen to anyone because my parents supported me. They said, yeah, go for ICT if you like it, because that's going to be the future. So you can go for it. So that is how I'm really happy that you people have chosen ICT instead of other subjects like health or any other subjects. So I'm really happy, and yeah, I'm seeing many answers. Yeah, same happened to you. Yeah. So yeah, this is what happens. Like not only teachers, but also the people around us. They started saying that ICT is hard. But am I lagging? Can't you hear me clearly? Okay, clear. Okay, fine. So that's it. So they started saying that don't go for ICT, go for other subjects, but don't listen. I didn't listen to them. So same like that. I'm happy that you people didn't listen to them. So ICT is a very interesting and a very useful subject. It's going to be the future. So if you wanted to be a software engineer, or if you wanted to pursue anything after your A levels, you're going to, this ICT is going to be really useful for you. Okay, so that now it's the introduction is enough, I think. So now let's get started. Okay. Okay. So okay, before starting, let me say you a quote. Technology is a useful servant, but a dangerous master. So this is it. Be very careful with technology. Yes, ICT is very useful, very easy, very interesting, but it is a very useful servant but a dangerous master. Servant means what? Servant is someone who listens to what we say, listens to our instructions, but a master is someone whom instructions we listen to. So you have to control the technology shouldn't control you, so be careful with that. And even if you're into the ICT field or in anywhere, so please you have to be very careful. You shouldn't listen to what all technology says and shows you. Okay, so with that quote we'll start the lesson. So today's chapter is going to be number systems. So this in grade 10, the entire, like the third unit entire is about number systems, like what is a number system, how we are going to what convert the number system. If one number system is given, how to convert it to the other number system. So this is all about the number system. So if you know this number system clearly, so you're going to take solid marks in paper. So if you see each year, you'll be like the questions will be repeated, like you will have they'll be asking you the questions about number systems, like in MCQ, in essay, everywhere. So if you know this, then you can take solid marks. So okay, fine. What is a number system? Number system means, like if you have a computer, probably you all might have a computer at home. So if you're having a computer, if you say something to a computer, like if you type something saying hello or anything, you type HALLO, you may think that computer understand it the way like hello. If you say hello, it will show you in the screen, you can see hello printed, right? But it's not like that. Computer is not going to understand any languages like our normal language. Maybe it is English or Sinhala or Tamil, anything. Computer is not going to understand any language. It is going to understand a group of numbers. That group of number is going to be this number system. That is called this number system. So any data representation, if you wanted to input data and any data representation in the computer, for that data representation, this number system is used in the computer. So the four number systems you want to know is, these are the four number systems. First one is binary, next octal, decimal, and hexadecimal. So if you know about all these four number systems, first you'll know what these number systems are, and then you'll start to learn to convert one number system to another. So that's all. You're in grade 10, this number system, this data representation unit is starting from, I think it starts from the page 68 and it finishes at 107 page number. So it looks like a large unit, but the content, the thing inside is it very less. Like if you know some little thing, if you know the conversions and all, then you can completely do the questions. I said solid marks. Okay, so fine. So these are the four number systems that we have. So about the number systems, these are the four: binary, octal, decimal, and hexadecimal number systems. And we are going to see the base value and the number used in that number system. So first, we are going to see the number system binary. If you are seeing the number system binary, so there is going to be only two digits, two numbers in it, two digits used, 0 and 1. If you take a binary number, only 0 and 1 will be in that number system. Okay. So this, if you take octal number system, it's going to be from 0 to 7. Okay, there'll be altogether 8 numbers, 0, 1, 2, 3, 4, 5, 6, and 7. So altogether 8 numbers will be there. If you take decimal is common. Like we all know the decimal number system, right? In day-to-day life, we use the decimal number system. Like for anything, we just use the decimal number system. So it is from 0 to 9. We combine the 0 to 9 and make large numbers and all. So in mathematics also, you use this number system. So decimal number system has 0 to 9. Okay. And if it is hexadecimal, it's going to be 0 to F. What does that mean by 0 to F? It means 0 to 9 will have a normal decimal number, and from the other 6 numbers will be from the English alphabet A to F. It means like the A will be equal to 10, and B will be equal to 11, and C will be equal to 12, D will be equal to 13, E will be equal to 14, and F will be equal to 50. So that is it. So from 0 to 0 to 9, you will have the normal decimal number, and then you will have some alphabetical letters in the hexadecimal number system. So this is the number system and the numbers and characters used in it. So what is this base value means? That the amount of number, the number used, that is the base of each number system. So if it is a binary, there will be only 2 numbers used in it, 0, 1. So that is the base value 2. In this octal, that is going to be 0 to 7. Altogether, there will be 8 numbers. So the base of that will be 8. Same decimal, altogether 10 numbers. So the base will be 10. And the hexadecimal, altogether, it is going to be 16. So this is what the base values. You will really need this base value when doing the conversions and all. Okay. So this is what a number system. These are the 4 number system and the numbers used in that number system and the base value of that number system. Is that clear for you? Okay. So yeah, I'll send you the slides later. Now, we'll move to the next part. Okay. So as I said, computer is going to be like when you input something in computers will convert it into the binary format. It is not going to understand other languages, any language you input, any hello or any words or letters. It's not going to understand that. It will convert it into the binary format so that it can understand. So binary is the format that is used in computer for mainly for the data representation. So binary means like, that is 0 and 0, 1. So you may think like this 0, 1, with this 0 and 1, can we change all the words to that? Can we convert it? Yes, computer will convert it. Maybe the string will be long, like 1, 1, 0, 1, 0, 0, like that. But still it will convert it into the binary format so that it can understand. So binaries of 0 and 1. And 0 will be, we say that 0, if you think about electronic circuit, the 0 will be of the low voltage level and 1 will be the high voltage level. This thing you will be okay. So when you think about a circuit, it's going to be like if you switch on a circuit, switching on is going to be said as 1 and switching off will be 0. You may get confused. Don't get confused. This thing is all about, you will understand this when it comes to the logic gates. So in logic gates, you will be studying the gates and the circuit of that gates. So that there, if you wanted to switch on, you will use the number 1 in truth table. And if you wanted to switch it off, you will put 0 in the truth table. So that is it. So it's not that much, like don't take it into like what is this high voltage and low voltage. It's not that much important. It's like when it comes to logic gates, you have to know that this 1 is going to be the on and this 0 is going to give you the off one. Okay. And so any data, as I said, in the word can, if you give any word to the computer, it will be converted to binary format. Okay, so now we'll go get into the we'll see each and every number systems now clearly, like decimal number system and then binary and all those things next. So first one is decimal number system. So decimal number system means like this is going to be the first number system we are going to see. You have to know decimal number system base is 10. I said you already, the digits used in decimal number system are 0 to 9. It means there will be altogether 10 numbers, 10 symbols used in there. So that amount of digits, amount of symbols used in here will be the base. So 10. So for each number system, you should know the base. Okay. So that base will be like it will help you when you do the conversions. Okay. Then okay. Normally in mathematics, you know how a decimal number system is formed. Like how a decimal number is formed. Okay. How a decimal number is formed is first, if they say 36, they say 36, there is a number called 36 and the base will be 10. For any number system, you have to put the base value. When it comes to the, mainly when it is ICT and ICT, when you're writing it in the paper, don't forget to put the base value. For decimal, yeah, like people will, even your examiners, so they will understand when you don't put the, if you didn't put the base value, they will assume it as the decimal number. But for other things, there will be 36 in octal also, 36 in hexadecimal also. So that time you have to definitely put the base value so that they can clearly understand that they have mentioned this as the hexadecimal value and the or else octal value. So okay, now we'll see the decimal, how a decimal number is formed. In mathematics, we know that this is called the ones place, the place value. This is ones place, and this is going to be tens place, right? So how it is formed? So you know there will be, we say that there is 3 10 and 6 ones. So that is how it is formed. Like there is 3 10, like 3 into 10, and 6 ones. So all this will be 30 and this will be 6. So we add it together. That is how the 36 is formed in the decimal number system, right? So this place, this ones place is denoted as 10 to the power naught, and this tens place is denoted as 10 to the power 1. The 100 place will be denoted as 10 to the power 2. How you know how you'll get 1 here. 10 to the power 1 will be 10, 10 to the power 2 will be 100. So that's how the place value of a number is formed, right? So in this will be, this can be also written as 3 into 10 to the power 1, because this is tens place. This 3 is in tens place, and this is 3 in 6 into, sorry, this is 6 into 10 to the power naught. So that is in the ones value. So that all together will give you 36 as the value. Okay. So these 10 to the power 1, 10 to the power 2, 10 to the power 0, all these things are called weighting factors of decimal number system. So these weighting factors and this base of a number system will be useful when it comes to the conversion. We will apply that into that for the conversions. So for example, the example of decimal number systems are 20. You can put the base. With the base, you can identify whether that is a decimal number system or other number systems. Okay, so this is the base 10 counting frame. Like okay, so if it is called an abacus, right? So this is what a counting frame is. So this place is going to be ones place, tens place, hundreds place, and thousands place. For the 36 number, we learned 36 base 10. So you know it is at the tens place, right? And this is at the ones place. So there is 3 point here, and there is 6 here. So that is how you can show the show the number in the counting frame. Okay, so same like that. How this 504 is formed in decimal? This is ones place, this is tens place, and this is hundreds place. So you have 5 into 500. So 10 to the power 2, 5 into 10 to the power 2, plus you have to add all that together. 0 into 10 to the power 1 plus 4 into 10 to the power naught. All this together will give you 500 plus 0 plus 4 and 504. So this is what a decimal number system is, and this is how a decimal number is formed. Okay. Are you okay, clear with that decimal number system? It's just very easy. We have already, you people will already know that because it's easy maths, simple math, right? Okay. Now we'll go to the binary number system. Next binary number system is actually it's going to be the in a number system. What you have to know is the base of that binary number system. So next base of the binary number system is 2. As I said, there is only 2 digits, so the base will be 2. Okay, if you insert any binary any decimal number into the computer, it will be converted to binary by the computer. So same like that, as we said, 10 to the power 0, 10 to the power 1, like that. These are the weighting factors of decimal number system. This 2 to the power 0, 2 to the power 1 will be the weighting factors of binary number system. Okay, so for example, this is one of the example of the binary number system, 110. All the numbers will be 1 and 0 in binary number system. So this is, you have, don't forget to put the base. Okay, so that is a binary number system. So when it comes to the binary base counting frame, so with this, this is the weighting factors, and this is the place value. You know, so 2 to the power 1 is 2, 2 to the power 2 will be 4. You know how that, if it is a power, how it is formed, 2 into 2, right? So that is how you got 4, the place values. So 2 to the power 3, 2 to the power 4 and all. So this number 1101110 is shown in this binary counting frame, because this is 1 1 0. There is no number, again 1 1 1 0. So this is what the number is, how the number is represented in a binary base counting format. Okay, so now answer me. This is a question for you, simple question for you. What is the basic measuring unit of a computer? Basic measuring unit of a computer. Anyone? Measuring unit of a computer. Okay. It's bit. Bit is the measuring unit of a computer. Computer speed or anything, like the basic measuring unit in a computer is called bit. Okay, what is the bit? Is binary digit. The first B and the last IT is bit. Okay, so if they ask you what is the basic measuring unit of a computer, it's bit. Bit is a smaller unit of a smaller measuring unit, and when it gets bigger, it will be byte. You say it as KB, MB, GB, TB, right? So that is it. So bit is a smaller measuring unit of a computer. Okay, so as we have seen the binary number system, next we are moving to the octal number system. So if it is the octal number system, the base will be 8. As I said, there's altogether 8 numbers, so the base will be 8. Okay, so same like that, we saw 10 to the power 0 is decimals weighting factor, 2 to the power 0, 2 to the power 1 will be binaries weighting factor. So this is going to be 8 to the power 0, 8 to the power 1, 8 to the power 2, and so on will be the weighting factor of octal. So for example, if you take 376, 376 is an octal number when you put the base there, like you have to put the base there. If not, you can also take it as a decimal number if you don't put the base. So be very careful with the base. Okay. So this is going to be the base counting frame of an octal. So if it is like 376, if it is 376, you know, here is 3. There is 3 in the 8 to the power 2's place. In 8 to the power 1's place, it is 7. In 8 to the power 0's place, it's 6. So this is a base 8 counting frame. So this is how the base 8 counting frame will be. So next one is hexadecimal number system. So if you wanted to see a hexadecimal number system, the base will be 16. As I said, 0 to 9, or that 10 numbers will be in decimal, and the other 16 will be in alphabetical letter A to F. It will be in order. A will be 10 and B will be 11, like that. So on till F, F is going to be 50. So the weighting factor of this hexadecimal number system will be 16 to the power 0, 16 to the power 1, 16 to the power 2, and so on. So As I said, 10 digits are from decimal 0 to 9, and other 6 digits are going to be the alphabetical letter A, B, C, D, E, F. And A will be equal to this and that. Okay. So now this example of an hexadecimal number can be 2, 1, A, and don't forget to put the base 16. This is how this is what a hexadecimal number system is. If you wanted to point it or show this 21A, 21A 16 in base 16 counting frame. This is going to be 16 to the power 0, 16 to the power 1, 16 to the power 2. So 2 is going to be at this place and 1 is here, and I have put 10 things here. Like altogether there is 10 because A is equals to 10, right? In decimal number system, A is going to be 10. Okay. Okay, I'll hold on because I can see messages saying it's Azan. This part, you didn't understand this part. Okay, listen to me. This part, right? This counting frame. So 2, 1, A, 16 is going to be a hexadecimal number. This is going to be a hexadecimal number. So this is the weighting factor, 16 to the power 0, 16 to the power 1, and 16 to the power 2. So this is the place of 2 because this is the place of 1 and this is the place of A. Because this is 2 clearly you can see. So this is going to be 2 and this is going to be 1. And why did I put 10 things here? 10 here. Why did I insert 10 here? Because A is equals to 10. Yes, A is equals to 10. So that is what 10 is here. Because this place value will give you a decimal value. Okay, so that you have to, there'll be 10 ones here. Do you understand? Okay, so this is just the base 16 counting frame. This is how we are just showing the a number in the counting frame. This is not going to come for your exam. Like they are not going to give you any counting frame and going to ask you. So don't get scared. Okay. Looking at this, this is just too simple to show that this is how the number is formed, like 2, 1, and 10. This 10 is that A. Okay. Okay. Fine. So hexadecimal number, as I said, binary is the one which is used for the data representation in computer. These hexadecimal numbers are used to represent memory addresses of the computer. Okay. So in computer, we don't, if there is a number called 0, 1, F16, this has a base of 16, but we don't in computer, if you see this, there'll be no base 16 called. Instead of that 16, if to show the hexadecimal number, there will be a hash in front or end h in front. So end h, this will be 0, 1, f, or end h, sorry. For example, it will be hash 0, 1, f or end h 0, 1, f. So in computer, if you wanted to see a memory address of anything, this will be shown like with a hash or end h, but you have to know that is a hexadecimal value. Okay, so fine. So that is a hexadecimal number system. And okay, so this one is actually this is our class. This is online ICT class. If you have any, like if you're having any problem with ICT, you can join our class. And so this is like on Saturdays we are having for the grade 10s and on Sundays we are having for the grade 11s. Some people find it really hard when it comes to the practical parts and all, like presentation, may it be the grade 10s presentations or Word or anything, or else if it is O levels HTML, mainly HTML part, they get confused. I've seen personally students asking me to explain it. like explain us this HTML, I don't get it, and all those things. So this is going to be a class with practical knowledge. Like I'm not going to overdo it, but you will understand it easily with a practical. Okay, fine. So if you are interested, you can join the class. Okay, now we'll continue the subject. Okay, we have completed the number system. So we have seen what 4 number systems are. Now we are going to the main major part, the conversions. So this is the king here in this topic. So these conversions we are going to do now. And you might have seen in your book, in your O-level book, a table called like binary to hexadecimal table will be there. That might have confused you. If you're going for the exam, this is for the exam purpose. I'm telling you, when you go to the exam, if they are giving any conversions, there'll be in part 2 also you'll have the conversions. Take your paper and put the table first. Like you have to input the table like 0 to 15, put the decimal numbers, and then the other side hexadecimal values for that 0 to 15. So you people will think, how do we have to memorize that table? No, I will say you a simple easy way. And then you can put the table in like in 1 minute, less than 1 minute. You can just put 0 to 15 and then put it easily. So when the hexadecimal conversion comes, I'll show you the table, how the easy table for you. Okay, so now conversion is altogether there are 12 conversions here. First thing, conversions means if they are giving you a number system, then you have to convert it to the other number system. If they'll ask you, if you are giving decimal number system a number, and they'll ask you to convert it to binary or octal or hexadecimal. So vice versa, again other number systems have to be converted to decimal. So decimal to binary, decimal to octal, decimal to hexadecimal, and we are doing it the other way, binary to decimal, octal to decimal, and hexadecimal to decimal. Okay, so once again, so when we are done with the decimal conversions, then we are doing the conversions with binary to octal and binary to hexadecimal, octal to binary and octal to hexadecimal, hexadecimal to binary and hexadecimal to octal. So there you will have, why didn't we have here binary to decimal here or octal to decimal here? Because already we have had it here in the decimal conversion. So that is why we are not having it here. Okay, so first we'll see this first 6 conversions, and then we'll see this other 6 conversions. Okay, so first thing is decimal to binary. So if they're asking you to convert a decimal number to binary, okay, like I'm going to explain you this. If you have any doubts, if you are not clear with it, you can just disturb me anytime to ask you questions. Okay, so fine. So decimal to binary, when you wanted to convert a decimal number to binary, what you have to do is first convert 23 base 10 to binary. First thing you have to do is division. Here the part is division, and divide the number by 2. 2 here is the base of the binary. Okay, base. So when they're asking a decimal number to be converted to any other format, you have to divide it by the base of that the other number system. So divided by 2. So you'll get, if you divide it by 2, what you will get? 11. 11 into 2, it's going to be 22, and the remainder here. So you have to write the quotient, dividing and writing the quotient here and the remainder here. So you have to divide it till you get that quotient as 0. So once again divided by 2, what you will get? 5. 2 into 5 is going to be 10. So 1 remainder. And once again by 2, you will get 2, and you will get 1 remainder. 2 into 2, 4, and 1 remainder. So again by 2, 1, 1 into 2, 2. So there is no remainder, 0, 0 remainder. So once again, till the quotient becomes 0, divide 1 by 2, it's going to be 0 times, right? So, and then the 1 will be the remainder. So write down all the reminders from bottom to top. Now you have to write the reminders from like bottom to top. 1, 0, 1, 1, 1 is going to be equal to 23. So this is what the first conversion is. Like divide your number by the binary base and write the reminders in the side. So when you get, when you're done, write the numbers from bottom to top. So there you will get the answer. That will be equal to your binary number. Okay, I'll send you the PDF after the class. Okay, so next question is going to be for you. Okay, now Hope you understood this. Can you do it for me? Do it and show send the answers, please. Convert 61 decimal to binary. Yeah, if you get any part 2 questions, in part 1 you don't have, you just have to mark the option, but if you get a part 2 question, you have to write the steps. Steps are important there. You shouldn't just write the answers, okay? So if it comes for the part 2 question, you have to definitely write the steps for all the conversions. Okay, now can you convert this 61 decimal to binary? Okay, I'm getting several answers, and some seems to be right and some seems to be wrong. Okay, so okay, we'll check it once again. Okay, I'll explain you once again. See, yeah, some people got right answer while some people got wrong answers. Okay, fine. So what you have to do is decimal, if they are giving a decimal number, to which number system you have to convert binary. So divided by the binary base. So it will be 30 because 2 into 30 is going to be 60. So one reminder. And again, till the quotient becomes 0, you have to divide it. So some people will find it hard to divide like this. So if you find it hard to divide like this, so make it fast. You can just divide it this way also, like this, and you can get the answer and put the reminder here. Okay. So fine. So the one reminder. So again, 15, 2 into 15, 30. So the reminder will be 0. Okay, there is someone raised hand. What? Can send me message. Someone raised your hand. Okay, fine. If you have any questions, just direct message me so that I can answer it. Okay, now if you wanted to, like you can, once again, divided by 2. So you'll get 7 because 2 into 7, 14, and then 1 is reminder. So again by 2, you'll have 3. 2 into 3, 6, 1 reminder. And again by 2, 1 into 2, 2. So 1 reminder. Finally, making the quotient 0 by dividing it by 2. So it becomes 0 and 1. So those people who would send this answer, your answer is right. Others, do check it, please. So 2 equals to 61 base 10. Okay, was that clear? Okay, yes, those people who got this answer, that's right. Other people? Aren't we considering the 0? The reason we are not considering the 0 is why in any number system, if 0 comes in front, that has no value. So we don't need to. Okay? Okay. So that is how the decimal to binary conversion is. So if a number is given in decimal and you wanted to convert it to binary, divide it by the base of binary. Okay? So that's it. So we have seen the first conversion. That's all. So second conversion is going to be decimal to octal. Once again, decimal to octal means you have to consider the base of this number system. If you wanted to convert any decimal number system to other number systems, you have to consider the base of this. Base of this is going to be 8. So what you will do? Divide the number given by 8. Divide the number by 8, and you have to same like that. You have to write the reminders here, and then same like that. You have to do the write it from the top to bottom to top. So that will be equal to the decimal number. So we'll do it. 186 now divided by 8 is will give you 2, and then 2 into 8, 16. So the 2 will go here, 26. That is going to give you 3. So remainder will be 2. So if you are having any trouble doing it like this, you can definitely take your time and do it quickly like this and get the answer. Okay, and get the reminder. So what you'll get here? 2, and you'll get 16, and then you'll get 2, 6. So 3 times, that's going to be 24, and you'll get 2 remainder. So the quotient 23 is here. You're going to put the quotient here and the remainder here. That's all. So again, divided by 8. Here you are going to 8 2 times, because 2 into 8 is 16, and then remainder will be 7. 23 minus 16 is 7. Okay, once again by 8, the quotient will become 0, the remainder will become 2. So do write it again, like from the bottom to top. 272 is going to be equal to 186. And don't forget to put the base value. So this is going to be 8 base, and this is going to be 10 base. Okay, clear? Okay. Have to write down. Yeah, down to up. You have to write it from down to up, bottom to top. Okay. Okay. Now this question is also, we'll do it together. And you can send the answers if you get the answers before me. Okay. I'll do it slowly. Okay. Now if you wanted to convert this 541 decimal to this octal, what do you have to do? Divide it by 8. So what you will get here? 6 times, and then it will come 7 times, 67 into 8. And then you'll get 5 remainder. Okay. And once again, you'll get divided by 8. So 8 into 8, 64. So 8. So you'll get 3 remainder. And once again, divided by 8, there you're going to get 1 and 0 remainder. And once again by 8, making your quotient 0 by giving 1. Check. Okay, so you have to write it from bottom to top. Remember that always. That is the main part. You cannot write it like 5301. Okay, you have to write it like 1035 is equals to 541. And always remember to put your base value. Okay, 135 to base. No, 135. You have to consider this 0 also in the middle. Okay, clear? Okay. So this is how the decimal to octal is. Okay. If you wanted to convert a decimal number to octal, there what you have to do is divide it by its base, the number system which you have to convert the decimal into. So like if it is octal, it will be 8. If it is binary, it will be 2. And if it is hexadecimal, it is going to be 16. So same thing you're going to do here, but divided by 60. The same steps, but the base is different. Okay. Yeah, I'll give you a sum to solve. Okay, so if you wanted sum to solve, okay, I'll give you sum in octal. Okay, so I'll put a message. Okay, no, I'll write it here. Okay, 49 is 10. Convert this to octal. Convert this to octal and send me. I'm getting several answers. And many have got the correct answer. So what is the correct answer? Answer is going to be, okay, we'll check it. 49, if you want to do divide it by 8. So what you will get? 6 into 8 is going to be 48, right? So you'll get 6 here, and the remainder will be 49 minus 48, 1. And once again, divide 8 by 6 by 8. There you'll get 0 quotient and 6 will be here. So 61. Okay, so those people who have got 61, that's right. Others, do check it. Do it slowly. Like you don't need to hurry up. Just do it slowly and recheck it. Okay, if you when you're doing it in the paper, don't forget to recheck it. Okay, you can, everyone can do it. It's just simple thing, but maybe you're when you are like in a hurry, it may like give you a different answer. So cross check it when you are done with it. Okay, it's simple. Okay, so we'll move to the next one. Okay, so convert this one to hexadecimal. So when you are doing the hexadecimal conversion, what you have to do is just divide the number by 16. So the base of the hexadecimal. So you have to divide it by 16. What you'll get? If you divide it by 16, you're going to get 1 time, because 1 into 16. So 1 into 16 is going to be 16, and that will give 27 minus 16 will give you 11. Okay, 11. And then once again divide it by 16. So you are making the quotient 0 by getting in 1. Okay, now, okay, from bottom to top, same procedure. So, okay, 1. And this 11 is not available. This is only available in decimal. So when you have to write it as a hexadecimal, what is 11 in hexadecimal? 11 is hexadecimal is B. Very good. So you have to write it as B. So don't forget about the base. So this is the answer. 1B is equals to 2710. Okay. So same thing. Okay, now, okay, same procedure, no? So you have to do it. Convert this 89 decimal to hexadecimal. Can you? Okay, let me explain you again then. Okay, so if you wanted to divide it, you divided it by 16. There you got 1 in 1, and then the remainder will be 11, and divided once again by 16. Then the quotient becomes 0, where you'll get 1. So this will be from bottom to top. What you have to do is, this is 1, and this 11 is going to be in this. I said the hexadecimal will be 0 to 9. From 0 to 9, it's going to be like a decimal number. But then from 10 to 15, it's not going to be 10 to 15. It will be A to F, right? So 10 is equals to, as 10 is equals to A, like, so A is going to be equals to 10, B equals to 11, C equals to 12, D equals to 13, E equals to 14, and F equals to 15. So there you can find this 11, B. In hexadecimal, B is 11. So you have to put it as B. Okay, that is how we got this answer. Okay, so now do this question, do this one and send me the answers. Yes, I'm getting answers already. Very good. I like your interest. Yes, very good. The answers I'm getting are very correct. Okay. So yes, divided by 16, the base of hexadecimal. So you're going to get 5 times, because 16 into 5 in multiplication table, it's going to give you 80. Okay, so the remainder is going to be 9. Yes, I'm getting correct answers. So once again, if you wanted to just divide it, this quotient becomes 0 and you'll get 5. So simple, 59. 59, 16. That is going to be the answer. Is that clear? Yeah, it must be, because you people are already sending me correct answers. Okay. So this is the decimal to other conversions, decimal to other number system conversions. Now we are going to see the other format, like vice versa, binary to decimal, octal to decimal, and then hexadecimal to decimal. There we used the base, right? There we used the base. Now we are going to use the weighting factors here. Weighting factors here. Okay, you might remember what the weighting factor is? How many hexadecimal we want to divide by 16? Yes, if it is hexadecimal, you have to divide it by its base. Hexadecimal's base is 16, so that you have to divide it by 16. If it is the binary, if you wanted to convert the decimal to binary, divide the decimal number by binary's base, divided by 2. If decimal to octal, then octal number will be like, you have to divide octal's base is going to be 8. So divide the decimal number by the octal's base 8. Okay. So hexadecimal will be, the number will be divided by 16 because hexadecimal's base is 16. Okay. So here we are going to consider the weighting factor. So when you here is going to be weighting factors. So I said when it comes to decimal, the weighting factors will be 10 to the power 0, like 10 to the power 1. Okay. And if it is like binary, it's going to be 2 to the power 0 and 2 to the power 1. So as we are going to convert binary to decimal, we are going to consider this binary weighting factors here. So they have given you 10102 to decimal. Convert this one to decimal. So if you wanted to convert this to decimal, what do you have to do? First write the numbers 1010 and write the weighting factors of it. Okay, 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. Same like the normal decimal, how a decimal number is formed. If they are giving you 10, you will say this is 10 to the power 0 and this is 10 to the power 1. Like you'll say there is 1 tens. So you multiply this value, this place value will be 10 and this place value will be 1. So you'll say there is 110 and you'll add it with 0 ones, right? That is how you got this final answer 10. Same like that we are going to do it here. So this place value is going to be, actually we are going to multiply this 1 with this, it's the place, this weighting factor. This place value will give you 8. 2 to the power 3 is 8. 2 to the power 2 is 4. 2 to the power 1 is 2 and 2 to the power 0 is 1. So, okay. So now what you have to do is same like that. So there is, you have to multiply this with this 1 with 8. Okay. Plus this 0 with 4. Same like that, like we did like this 1 with 10 and this 0 with 1. Okay, so we are doing it 0 into 4 and then plus 1 into 2 and also plus 0 into 1. So you'll get, what you'll get? 8. Any number divided, sorry, multiplied with 0 is going to give you 0. Then 1 into 2 will give you 2. And once again 0 into 1 will give you 0 and the answer will be 10. So decimal. So this 1010 in binary is equals to 10 in decimal. Okay, clear? Is that clear? Hope it's clear. I'm not making, like, I'm not boring you. Okay. I don't think I'm boring you. Do I? Am I actually? Am I boring you? Okay. Okay. If you are saying no, okay, fine. I'll take it as a compliment. Okay. Thank you. Thank you so much. Thank you so much. Okay, fine. So we'll continue it. Then. Okay. So fine. So it will be clear for you, I think. So we'll move to the next part. Like this is a question for you. Now what you have to do is put the weighting factors down and then do the question and send me the answer. And I'll show it to the other peoples, like who are finding it hard. I'll just show you. Put the weighting factors first. If you have any question, just ask me. Feel free to disturb me, okay? But regarding the subject. Okay, so I'm waiting for the answers. Okay, but I'll do it. So you have to know the place values: 2, 4, 8, then it's going to be 16, and then it's going to be 32. When you do it repeatedly, like these questions, you will know the base values. Like 2 to the power 5 is 32. You already will know because you studied mathematics, right? Even if not, you will get used to it when you do the questions. Yes, I'm getting the answers. Okay, so now what you have to do is you have to just repeat the same thing. 32, sorry, 1 into 32 plus, once again, 1 into 16 plus, it's going to be 0 into 8 because there is no 8s because 0, plus 1 into 4 plus 0 into 2 plus 1 into 1. That's going to give you 53, as you all said. Okay, I can see many values and I can see different questions which I don't get it. Can you make your question clear, please? Okay, so that is it. So you have to put the weighting factors and then you have to just multiply the number with the place value. So you'll get it. Add it together, then finally you will get the decimal value. Okay, so that is how the binary to decimal conversion is. So you have to just grab the method here. Okay, like as we have only 1.5 hours, I'm not able to give you so many questions and so like discuss even more. So you just grab the method how we are doing it. So then you can practice many questions. Okay. So when you are going to finish this, I'll give you a quiz. Okay, simple quiz that I'll send you the link so you can do it. Just it'll only take like 3 questions. You have to do it, and then you'll be you'll be given the answers to it. Okay, so you can check the marks, 30 out of 30 or anything, but it's going to be easy. Just grab the methods. Okay, grab the steps that I'm telling you. Okay, so now we saw binary to decimal, now octal to decimal. In decimal to other number system conversions, we use divided the decimal number by the base. But other number systems to the decimal conversions, what we have to do is just consider the weighting factors. In binary, we consider binary weighting factor. So in octal, we have to consider octal weighting factors: 8 to the power 0, 8 to the power 1, and 8 to the power 2. So this will give you 1. 8 to the power 1 is 8, and 8 to the power 2, 8 into 8, 64. So same method, 5 64s are there, 5 into 64 plus 4 8s are there and 3 1s are there. So 5 into 64, you will get 320, and 4 into 8, it's going to be 32 plus 3. Then your answer is going to be 355 to the base 10. Okay, I have a question like, what kind of tips do you prefer to get A results for students? More practicals or more theory? It's like, just don't go get into so much of theory, okay? Because I didn't get into theory. I always loved IT, and I like, yes, I'll come to the next one again. Okay, so I was like, when people said don't take IT and all those things, I was like, I loved IT, so I was like, okay, I'm going to take IT. So I took IT, and I didn't even care whether I had a good teacher or not. I just used to study on my own. But the thing is, do the papers. Papers means questions. Do it was like questions, okay? And my O-level IT result is A, okay, because I loved IT. So whenever my parents wanted me to study, I'll just sit with the IT book. Because I don't study seriously, I don't study more a book, okay. I've got questions, these methods easy into my writing book, and I will only study that, okay. So in A-level also we had JIT, and there I got A again. And I did bio for A-level, and then when I couldn't, like, I did, my research was not enough to get into medicine. So my if I couldn't get into my idea was like, if I didn't get IT, sorry, get medicine, then the priority I had is IT. And my mother was like, yes, go for IT because you love IT, so that is your way, just get into that. So that's it. So if you wanted to take A pass or good results in IT, you just go with the, don't overdo the theories, don't just study the book, just these simple methods, just have it. Even, okay, keep this in mind, I'm going to show you the table, okay, an easy table. That table is going to give you, like, make the conversion even more easier for you, okay. So so like that, so do the simple methods, like grab the easy things that you can get from it, like simple things. Don't study the book. And for the only part where I studied the book is for the short notes, right? We were asked to write short notes in our paper that time, in our oral papers. Like, so we have to get ready for the short notes. So we will study the first unit. That was the theory part, where we will need to know the Ada Augusta Lovelace and Charles Babbage and all those things. So we should know that. So for that I studied theory. Other than that, so focus on the question papers or questions. Okay, take it as a short note and study. Okay, okay. And yeah, I have seen many people struggling with this unit. That is why I chose this unit for the seminar. Okay, so okay, we'll continue it. Okay, yeah, you have a table here. This table, I'm going to show the table for the conversion. Then you'll be like, you'll feel even this unit will be even more easier for you. Okay, so fine. So we'll continue with the topic, octal to decimal. I hope it will be clear for you. Okay, now can you do this question? You have to do the weighting factors. You have to use the weighting factors. Can you? I get an answer like no. No means what? For which question? Did I ask any question? Okay. Okay, fine. Do it quickly. I will also do it. A to the power 0, a to the power 1, a to the power 2, and a to the power 3. So it's going to be 1, 8, 64, and what is this? 5, 1, 2, 512. 64. This looks so bad. Okay. So now 2 into 512. I have to, the next rest of the part is just going to be the addition stuff. 1 into 64, and then 5 into 8 plus 7 into 1. That is going to give, let's see the answers. No, I'm getting binary answers. We want to convert the octal to decimal. So you have to just add it together. 2157 is, yes, correct answers. 1135. 1135 base 10. Okay, so I wanted to show you the method. So that is what I've done it so like in a fast way. So it's okay. You take your own time to the for the multiplication, for the addition, take your own time. It doesn't matter. Okay. So the method, you have to grab the method, like this is what it is. You have to use the weighting factors here. Okay, very good. The answer is right. Okay, so octal to decimal. Now we are moving to the hexadecimal to decimal. So when I same thing here, we are using the weighting factors, but the weighting factor of hexadecimal. It's going to be 16 to the power 0, 16 to the power 1, and 16 to the power 2. So this is 1, 16, and 16 to the power 2 is going to be what? 256. Okay, so same method, multiply it by 2 into 256 plus 1 into 16 plus 8 into 1. Sorry, that's okay. So 2 into 256 is going to be 512 plus 16, 1 into 16 plus 8 into, this looks so ugly. Sorry about it. Okay, so when you add all this together, you'll get 536, the base 10. I think if people are having trouble with just multiplication and thing, because as you're doing it in a faster, like you're doing it in a hurry, you are just getting little wrong answers to check it again. Okay, you'll just in papers also, it's these questions will give you solid marks. So when you have done, you cross check it once again. Okay. Okay, so now this question is for you. CE5, convert this hexadecimal to decimal. Thank you for the comment. Okay, so you have to convert it. So it might be a little bit confusing as you see alphabetical letters here. So first of all, you have to put the weighting factors: 16 to the power 0, 16 to the power 1, and 16 to the power 2. Don't get confused. This C in decimal is what? This C in decimal is going to be 12, right? Yes. And this one is from, so this E is actually 40, right? So this is going to, now it's clear, right? So C, and when you saw it as C and E, you got confused, but now it's 12 and 14. So you can do it, right? So this is going to be 1, 16, and 16 into 16, 256. So the same process. Now instead of multiplying C into 256, you'll do with the 12. 12 into 256. And plus 14 into 60. And plus 5 into 1. So do the calculations properly and you'll get 3072. 12 into 256 plus 14 into 16, you'll get 224, and 5 into 1 is going to be 5. And the final answer is going to be 3301 base 10. Yes, I'm getting correct answers and I'm happy about it. Okay, so this is how you are going to change the hexadecimal to decimal. So we have used the weighting factors. So now we are done with the first 6 conversions. So we'll go to the other conversions. Okay. So now the next thing is binary to octal and binary to hexadecimal. So concentrate in this one. Okay. Like largest digit in octal number system is going to be 7, right? 0 to 7. So the largest number is going to be 7. So you have to know something like the relationship between the binary and octal and decimal. So 0, 1 from, okay, if it is decimal and if it's going to be octal, from 0 to 3, 4 to 7, okay, to 7, this decimal number will be equal to the octal number. So 0 of decimal is equal to 0 of octal. 1 of decimal is equal to 1 of octal. So till 7, the decimal will be equal to the octal. So for the binary also, binary of decimal will be equal to the binary of octal. Okay, so that we have the binary here. So binary of this will be 0, 1. Then this is going to be 1, 0. This will be 1, 1. When you convert it, you will know it. Okay. So like that, it will go on. So this binary of this decimal till 7 will be equal to the binary of octal also. So when I said, when I said 0 to 7, the highest number in the octal is 7. So the 7 can be, the binary of 7 will be, in decimal, it will be 1. So it will be equivalent to the octal. So that is also will be 1, 1, 1. Okay. This is the binary of 7. Okay, wait. Questions. Which one did you get? Which should I say again? Oh, sorry, I couldn't check it earlier. This binary to octal one, the table. Do I want to say about the table? Now, the one I explained now. Okay. Listen to me carefully. So the thing is, if you see the 0 to 7, the number from 0 to 7 is the number of octal. Okay. In decimal also, you have 0 to 7. Okay. In octal also, you have 0 to 7. Decimal also, you have 0 to 7. I'll put D for decimal and O for octal. The 0 of decimal is equal to 0 of octal. Okay. To make it clear, wait a minute. Wait. I'll explain you clearly. Okay. So now this is the decimal number. This is the octal number. Okay. So if you wanted to from 0, 1, 2, 3, 4, 5, 6, 7. This number of 0, decimal in 0 is equal to the octal in 0. Okay. Because same numbers, it has same numbers. So this is equal. Do you understand that? Can you understand that? As we say, like, yes. Okay, you can understand that, right? So decimal from octal will have 0 to 7 only in number. So decimals 8 is not available in octal. So we cannot say 8 of decimal is equal to 8 of octal because there's no number called 8 in octal. So till 0 to 7, the decimal of the decimal number is equal to the octal number. Can you understand that? Okay. So binary of this decimal. So if you find the binary of this decimal, binary will be 0. How we find the binary? We are dividing that by the 2. So that you will get, sorry, for this, you will divide the decimal number by the base of binary. So you'll get the binary number. So there you'll get 1. For 2, you'll get 1, 0. By dividing, you'll get it. And I'll say you the table, the easy table after this. Okay, when it comes to the hexadecimal conversions, I'll say you about the easy table, very easiest table. Okay, now the 3 will be 1, 1. 4 will be 1, 0, 0. 5 will be 1, 0, 1. 6 will be 1, 1, 0. 7 will be 1, 1, 1. So now this is equivalent to this binary is equivalent to this decimal. This 0 is equal to 0. This 1 of decimal is equal to 1. 2 of decimal is equal to 1, 0. As this decimal is equal to, from 0 to 7, decimal is also equal to octal. This binary will also be equal to octal. Did you understand that? That is the concept I'm trying to say you here. So this octals 2 is also equal to 1, 0. Octals 3 is also equal to 1, 1. Is that clear? I do want the answer. Clear? Okay. Anyone? Any others? Clear, no? Simple concept. This one is this is equal. So this is also equal to this. As this is equal, this is also equal to this. This is equal. This is equal. So this is equal to this. A equals to, simple, no? A equals to B. Then B equals to C. So A equals to C. Hence proved. Okay. So that is what I was trying to say. Okay. Okay. So that will come back to this binary to octal. It's already 8:20. So do you have anything after 8:30? Any class? Like it'll finish in 15 or 20 minutes, but like if I just if it takes 5 or 10 more minutes, will it be okay for you? Because okay. Okay. So hope I'm not boring you. Okay, so I'll try to finish it quickly, but you have to understand, right? That is when I'm taking time. Okay, so binary to octal. Now, as that is what I tried to say, 0 to 7. So the largest number 7, sorry, the largest number 7 is 111. Okay, so this is 111. So you can 3-digit format. You can see it, 3-digit format. We have written it as 111. So we can also write other octal numbers from 0 to 6 also in 3-digit format. If it is 2 is in binary, it's just 10. But to make it 3-digit format, we'll add 0 in front. The 0 has no value, right? Any number, if we add 0 in front of that, you're not going to have any values. But still, we'll make it 3-bit format for the conversions. For the conversions, we really need 3-bit format for octal and 4-bit format for hexadecimal. As why 4-bit format for hexadecimal mean the largest number is 15. It means F is in decimal 15, no? 15 in binary is 1111. Okay, so this is 4-bit format. So for the conversion, there we will change, if it is 2, we will change the number, the 10. We will add 2 zeros in front to make it as a 4-bit format. Only for the conversions we need this. Okay, when we are doing the conversions, you will understand it. Okay, so when we have we have to write it in 3-bit format. Now we'll come to the conversions. Binary to octal. This is the table, simple table. I said like octal, here decimal number will also come 0, 1, 2, 3, 4, 5 and so on till 7. So that is equal to octal's number. So that is the binary of decimal is equal to the octal number. That is what I explained you clearly on creating a new slide. Okay, now the conversion. We'll come to the conversion. Convert 101110101 to the octal. What you have to do is first write the number and then divide it by into 3-digit clusters. 3-digit clusters. Did you get that? You have to. I said 7 has 111. So the largest number 7 has 3-bit one. So that is why we are also dividing it into 3 bits. 3-digit clusters. So then for each clusters, you are going to find the octal number. For 101, check. This 101 is 5. With the help of table, it will be easy for you. 5. And for 110, check. 110 is 6. And once again, 101 is 5. So it's going to be 5, 6, 5, 8. Clear? That's simple, right? Very simple. Okay, the table is like decimal number is 0, 1, decimal for D, I'm putting for decimal. In table 0, 1, 2, 3, 4, 5, 6, 7. The decimal number is equal to the octal number from 0 to 7. We can just see clearly, right? 0 is equal to 0, 1 is equal to 1. In octal or decimal till 7, because 7 is the largest number in octal. That will be equal to the decimal number. So this binary number, we found it using the method of decimal to binary method. That is how we found this binaries. So that will be equal to octal. Okay. So if you have that, if you have this table, you can directly find this 3-bit. When it comes to 3-bit clusters, you can directly find the octal value. 101 is 5, 110 is 6, and 101 again is going to be 5. So the answer is 565. Clear? Yes, in here you have to write the number from, yes, you got confused because of the 5 with both sides. You have to write it from right to left. Okay. Sorry, left to right. This side is left. Okay. Sorry, left to right. You have to write it from left to right, not from right to left. Okay. Left to right. Sorry for the left to right. So 565. Okay. Okay. Write it from left to right. Clear now? Okay. So now we are going to see the, let me give you an example so you can do it. Okay, after explaining this one also, I'll give you a question, okay? First, let me explain you this one also, binary to hexadecimal. Okay, largest digit in hexadecimal, I already explained you. F is going to be 15. So the binary of 15 is going to be 1111. Same like that, octals 1. It is 4-bit. So we can write this 2 and 3 also in 4-bit by adding zeros in front. For the conversions, we need this. Okay, that is how we are going to make the binary equivalent hexadecimal. So same concept, same thing, but 4 bits, 4-digit clusters here. There we had 3-digit clusters. So next, okay. Before getting into that, I said I'll explain you the table, right? Now it's time for the table. So if you have this hexadecimal table, you can get the values easily. Like, okay, 1011, what is that? B. Okay, B. You can do the conversions easily. So let me explain you the table now. Okay. So looking at the table, you will find it like, okay, do I need to memorize this so that I have to do the exam? So in exam, I need this table. Yes, what I used to do is I used to go to the exam hall, and when I get the paper, I used to put the table from 0 to 50 and then write the binaries for that. So it's easy. Like, don't think that I divided each number and got the binary. It's just a simple method. Just look at me, okay? You can notice that first there'll be altogether, there will be, you can see 16 numbers, right? 0 to 15 means altogether 16 binary numbers are there from 0 to 5, 0 to 15. So what you have to do is, for the first 8, you have to put zeros. 2, 4, 6, 8. Okay. For the other 8, you have to put ones. Okay. For other next one, for first 4s, you have to put zeros, and other first 4s, you have to put ones. Again, repeat it, 4 zeros and 4 ones. And here, 2 zeros, 2 ones, 2 zeros, 2 ones, 0, 0, 1, 1, 0, 0, 1, 1. Finally, 0, 0, 1, sorry, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Did you get it? This is how we form the table. Just check it with it. So you'll have 8 zeros at first, and then 8 ones. 4 zeros, 4 ones, 4 zeros, 4 ones. 2 zeros, 2 ones, 2 zeros, 2 ones, like that, and 0, 1, 0, 1, 0, 1. So this is how the table is formed. So this will be equal to 0, this will be equal to 1, this will be equal to 2, like that, till that it will come to 15. This is the table. If you write it on the paper, like go get they'll give you rough sheets, write it, and then all the conversions, even for the binaries, you can have it as a 3-bit one. You can identify with the 3 bits. Only for till 7, you will have binary for octal, because 7 is the largest number. So from until this, you can have it. You omit the first zeros for the octal, and you can have the other numbers to identify it. 0 is, okay, where is 100 is here. Okay, 100 is going to be 4, like that. So this is the table. Do you understand? Very easy method, right? Yes. So you can just, you don't think that it's hard. It's just simple. This is an easy method I found it. So same like that, you have to just find your own ways. Just get it. So just put 0, 0, zeros. First 8, 8, then 4, 4, then 2, 2, then 1, 1. Okay. So that's how you formed it. It's simple. So we're having this this table, you can do the conversions easily. So skillful in ICT. The question is, okay, the thing is because I love ICT. So I'm an IT undergraduate also. So I have to know things in ICT. That's it. When you should use this table? Yeah, I'm coming to that point. Okay. So when you're converting the binary to hexadecimal, same step. I said you have to, for octal, you have to divide the numbers into 3 clusters, 3-bit clusters. But here, as the largest number has 4 bits, here you divide it into 4 bits and have it. So, okay, so 1111, if you don't get it, what is this one? You asked me where to use this table. So this 1111, so you know, you need to know this 1111, what is it? So if you have the table there, wait, let me show you. So with the table, you'll be able to identify 1111 is F. So that is going to be F. Okay. And so other one is, the other one will be 10011. Okay, if you ask me why I added 2 zeros in front, because I said you have to make it as a 4-bit cluster. Okay, 4 digits should be there. So though, like, if you add 2 zeros in front also, it's not going to make any sense. Like, it's not going to change the value, so that you can easily just add 2 zeros in front to make it 4-bit cluster. So 10 is going to be, with the use of table, if table is there right next to you, you can see that 10 is going to be 2. So this is 2. Okay. So this is going to be actually 2F. The answer is 2F16. Okay, clear? This is how you have to do the conversions. Why we are dividing it into 4 bits? I said you 15 is the largest number. It means F is the largest number in hexadecimal number system. So F is, as I showed you, F is 4-bit 1111 in the table. Okay, 111, as it is 111. So you have to, for the conversion, that is the method, like you have to write everything in 4-bit, 4-digit format. Then only you'll get the correct answer. Then only you'll get the right converted number. Did you get it? Yeah, in front, if the 0 is there is like actually no value to it. Even if it is a 53 decimal number, 53 rupees or something, if you add 0 in front, it's not going to give you any value in front. Same like that also for other number systems also. If you add any zeros in front, it's not going to give you any meaning, like any value. Why? It is in the corner, right? So I said like left to right, you have to write it. So as it is in the corner, you might not need the zeros. But if the number extended to this one also, if you have a number like this comes in the middle. Okay, so you have to add zeros to make it a big number. Okay, so don't get confused. Just add zeros to make it 4-bit clusters. Okay, thank you. Okay, fine. So that is how you're going to do it. So that is how the conversion is. Now we are going to see, we saw octal to, so we saw binary to octal, binary to hexadecimal. Now we are going to see octal to binary and octal to hexadecimal. So this octal to binary is convert this octal number to binary. Here what you have to do is very simple, very, very simple. So 531, write the number and write its binary with 3 bits. Okay, 3 digits. If it is 1 in binary is 1, right? But here the rule is you have to write it in 3 digit. Okay, so put 2 zeros in front and make it 1. If it is 3 in binary, you can see the if you see the table, you will understand. So 3 will be 1 1. So to make it a 3-bit one, add 0. For 5, it is going to be 1 1 0. Sorry, 101. 101. So it's already in 3 bits, so no need to add any zeros. So next step is from left to right, just write it down all together. 101 011 001. So that is it. Simple, very simple. Just write it in 3-bit and that is the number. Clear? If you have any questions, if you wanted to ask me any questions, you can contact through the number in the poster, in the flyer. Okay. So someone raise the hand. Have you got any doubt to ask? Like, have you got anything to ask? If so, put me a direct message so that I can answer you. Can you explain again? Okay, fine. If this number has to be converted to a binary, just write the number, and below that number, write the binary format for it. Binary format mean I already showed you the table, right? Write the table, and from the table you can get it. For one, binary is 1, but here as it is octal, you have to add 2 zeros in front to make it 3-bit. Okay, 3-digit format. Okay, so that is how you have to add it. For 3, the number is 1 1 in binary, so add 0 to make it a 3-digit format. 5 is already 101, so we needn't to add any zeros. Okay, so from left to right, combine it together and write it 101 011 001. That is equal to the 531 base 8 octal number. Okay, fine. Yes, any questions? Yes, if you want to contact me, you can message to the number provided on the flyer. It means like I'll show you the flyer at last. Okay, I'll show you the poster. Okay, fine. Now okay, so octal to binary is like that. So okay, this is the part a bit like you will feel like octal to hexadecimal means you have a bit more steps. Like that is one direct step 1, but this is going to have 2 steps, but easy steps only. First thing what you have to do is octal to hexadecimal means first you have to convert the octal to binary and then binary to hexadecimal. You have to convert it like this. First, you are doing the octal to binary conversion and then that binary to hexadecimal. Simple thing. First, say me octal to binary means how are you going to convert it? As I said, this octal, you have to write it in 3-bit format. For 7, it is going to be 111. You can just check the table, or else you can write the table and then you can check it. Okay. For 0 also, as it has no values, but we are converting it, right? It's in the middle, so it has values. So you are going to put 3 zeros to make 3-digit format, because that is a rule. For 1, it is 1 in binary, but add 2 zeros in front. Okay. For 2, it is going to be 0, 1, 0. So now from left to right, combine it and write it together. You will get 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 1, 1. Okay. So this is the number you got. Now what you have to do is, now once again you have to convert the binary to hexadecimal. Binary to hexadecimal we already studied. When they are giving you a binary, divide it into 4 clusters. So like 4-digit clusters, so that you can directly convert it. 111 is same 7 only. You can check the hexadecimal table, right? The table I explained you. Just put 0, 0, 0 and then you will get the table. So 7. This 1 is 2 to the power 2's place, 2 to the power 0, 2 to the power 1, and 2 to the power 2. So that is 4. And this is again 4. You'll get 4, 4, 7, 16. That is going to be equal to 21078. So the thing we did here is convert the octal to binary and then binary to hexadecimal. Okay, clear? Is that clear to you all? Clear now? Okay. So simple step, octal to hexadecimal means you have to convert octal to binary first and then binary to hexadecimal. Now final 2 conversions, hexadecimal to binary. After this we are done. Okay. Hexadecimal to binary means what you have to do is, if you wanted to convert the hexadecimal to binary, write the binary number and then same like octal, here binary for hexadecimal, we have to write it in 4-digit format. So for 6, you can see the table is going to be 1 1 0. Okay, so to make it a 4-bit, add 0 in front, 0 1 1 0, and for 8 it is going to be 1 0 0 0. So you needn't to add any zeros. It's already in 10 in 4-digit format. So combine this together from left to right, 0 1 1 0. Okay, clear? This is going to be equal to 86. (16) equals to, sorry, I have changed the side, 2 equals to 60. Clear? Okay, so that's clear. That's easy. So final one is hexadecimal to octal. The same way how we did the octal to hexadecimal. Like there, what we did the 3-digit, we took the 3-digit format clusters first, and then we joined it and then divided into 4-digit clusters. Here, the other vice versa. For F, it's going to be already 4-digit. F is 15. Remember that 15 is going to be 1 1 1 1. So you are going to write it 1 1 1 1. And for A, it is going to be, A will be 10. So 10 is 1 0 1 0 in binary. You can check the table. So for 2, it's going to be 1 0, just 1 0. But you can add 2 zeros to make it as 4-digit. Okay. So now what you have to do is you have to combine it all together. 0 0 1 0 1 0 1 0 1 1 1 1. Okay. When you write it together, then what you have to do? As I said earlier, now as you are converting to octal divided into 3-digit clusters, sorry, it's going cross version. Okay. So now get it done. It's not clear. Wait. Let me show you clearly. 0 0 1 0 1 0 1 0 1 1 1 1. Okay, this is the number. Now what you have to do is divided 3 in 3-bit format, 3-digit format. So you are getting it. 1 1 1 will be, table will be 7. 1 0 1 will get 5, and this will be 2. 1 0 is 2, and this is 1. So 1257 octal number is equals to 2AF16. That is the conversion. Clear? Is that clear? Okay, so these are the methods, just easy. Okay, here what we did is converting the hexadecimal to first binary, and then combining all the binary together, and you are dividing it into 3-digit form clusters, and then finding the octal for each clusters, and then you will have the octal. So these are the 12. So okay, these are the 12 conversions. So this is what your third unit is. This is all in your third unit is. If you got any questions, you can ask me. Okay. So let me explain you about the third unit. So that is a third unit. So you have to know the conversions and all those things. Other things are this, mainly these conversions is the main part, and then you'll have little extra like little part like ASCII code. You can just go through and then you will understand it. So just coding system. So don't get scared looking at the charts, tables. Oh man, these tables. Do we need to memorize all these tables? No need to memorize all the tables. It's going to be easy subject. ICT is completely easy. Like you can do it. And that's all with the number system. That's all with the seminar actually. I think I took 10 more minutes. Like we started at 7:05 and now it's 8:45. So sorry for taking extra time. Maybe I took some extra time for you. Okay, so let me say you, this is a this is a class, my class. for grade 10 and 11 English medium ICT students. So on Saturdays, we have grade 10, and on Sundays for grade 11s. So if you are interested in to like be in my class, if you want a ICT class, so you can contact us, and you can, yes, contact us. That's it. So you can see the poster. And okay, to study Excel and all this, like to study Excel or anything, like I can show you like in the practical wise. So you can, if you join my class, I can show you. Okay, fine. For as you asked to study Excel, just go through that simple. Like study with the don't just study the book. Okay, if you have the computer, open the Excel spreadsheet, like open the Excel application, and then you have to do it. What they are saying, you have to apply it and see. Okay. Yeah, like Excel is like, you don't just study the book. Okay, if you wanted to or like study Excel, or maybe it can be Excel, or it can be PowerPoint, or it can be Word, everything you have to go through the application. Okay, so you have to see the software in your, you'll have Office, right? Microsoft Office package in your computers, so you have to study with that. You shouldn't just go through the book. We didn't even go through the book. I didn't even go through the book for that. I had all those things in writing books in short forms, so I just applied it on the applications, like the on the Word and all those things. I studied it practically. So studied practically. Okay. So if you, that's all. Like if you have any other questions, you can ask. Okay, welcome. Thank you so much. Okay, so that's all. If you have no other questions, so we are going to finish the seminar. Okay, thank you. Thank you. Okay, fine. Okay, so no doubts. Thank you. So you have to just go through the same format will repeat in your papers. You go through the past papers. Every year the format will be same. The numbers, the questions, like the binary numbers will be different. Okay, so just go through the questions. You will have flow chart. You'll have conversions, and you'll have logic gates. All those things. So you have to just go through the past paper format. Okay. Thank you so much. Okay. Okay, we'll finish then in the class. Thank you.